Good morning, guys. I hope this finds you all warm and safe at home. We are looking at some more SOHCAHTOA type problems, but now these are going to be real world problems. So the biggest thing as you read through this, I'm going to do a little bit of annotating, is that you get the numbers that they give you in the right spot on the triangle. So I'm going to first start by drawing a triangle. All of my triangles are going to face the same direction today. They're all going to face like this. I'll put the right angle box in, and then I'm going to work the numbers in the problem around it. So it says, from a point on level ground about 80 feet up from the base of the Eiffel Tower, about 80 feet from the base of the Eiffel Tower, the angle of elevation is 85.4 degrees. We want to approximate the height of the Eiffel Tower to the nearest foot. So the first number they gave us, the 80 feet from the base of the Eiffel Tower, that number we know is going to go along the ground. So that's going to go here. The next number they gave us was the angle of elevation. The angle of elevation is 85.4 degrees. The angle of elevation always goes between the horizontal line and the hypotenuse. Write that down, between the horizontal line and the hypotenuse. So when you're looking at the triangle, if you find the horizontal line and the hypotenuse, that angle of elevation will always go there. If you always draw the triangle this way, it'll always be that bottom left corner. But if you switch it around, if for some reason you want to draw it upside down one time, it won't be necessarily that corner. So it will always be between the horizontal line and the hypotenuse. They both start with H. And then the last thing that it gave us was what we wanted to find. That's going to be X in the picture. We want to find the height of the Eiffel Tower to the nearest foot. So I'm going to call that X in the picture. I know that the X goes there because it's talking about how tall it is, and if it helps, you could draw a little. This will be a really bad drawing, but you could draw, here's the Eiffel Tower. A little bit of drawing might help. So then we are going to solve this. Right now I have opposite and adjacent from the 85.4 degree angle. So it's going to be tangent. Tangent of 85.4 is equal to OX over A 80. And then we're just going to multiply each side by 80. And you'll type that in your calculator. And it does want us, since it's a word problem, we're not going to do a decimal for this particular one because it says round to the nearest foot. So it's going to be rounded to 994 feet. All right, let's try another one. Excuse me, guys. All right, this next one, I'm going to start by drawing the triangle. And it's talking about a guy wire, which is just a wire. If you've ever looked outside at a pole, or sometimes they use them with trees to support them, it's just a wire that connects from the top down to the ground. So it's a guy wire is 13.8 yards long and is attached from the ground to a pole that is 6.7 yards above the ground. Find the angle to the nearest tenth of a degree that the wire makes with the ground. So let's pick out the key things here. So it says the guy wire is 13.8 yards long. So you really need to think about where that says it's going. It's going from the ground to the pole. So it's that whole side right now. And if it helps, we can draw. Here's our pole here. So the 13.8 is actually on the hypotenuse because it's looking at the line that's slanted. The wire is going to be slanted. It's going to go through the air. So that's got to be on that slanted side. Then the next thing they gave us is that we know from the ground to the top of the pole is 6.7 yards. So this is going to be 6.7 here. That's the height of the pole. And we want to find the angle that it makes with the ground. So we want to find the angle that it makes with the ground. So that's going to go on the ground. It's going to be this angle right here. That's X. So again, we're going to look from the angle and label our sides. This is opposite. This is hypotenuse. So we're going to use sine. This time we're trying to find the angle. So it's sine of X is equal to opposite over hypotenuse. Make sure you put these in the right order, because if you don't, you're going to get an error on your calculator. And then we need to solve for the angle. So again, we talked about this yesterday, is in order to get rid of sine, we're going to use sine -1. The inverse of sine cancels out the sine, so x is going to be, you're going to type in your calculator, sine -1 of 6.7 over 13.8. Make sure you're in degree mode still, please. And we get 29.0 degrees. Alright, here's another one. These next couple are using two triangles. So that's the math here is just going to get a little bit more complicated, because we're going to have to think about, first locate the two triangles and then think about what we need to do to answer the question. So it says you are standing on level ground 800 feet from Mount Rushmore, looking at the sculpture of Abraham Lincoln's face. The angle of elevation to the bottom of the sculpture is 32 degrees, and the angle of elevation to the top is 35 degrees. Find the height of the sculpture of Lincoln's face to the nearest 10. I'm going to zoom in here a little bit. I'm going to draw these triangles in. So here we are standing on the ground looking up at the faces. So it said we are 800 feet from where the statues are. So this is 800 feet along the ground. So that was that first clue there. They gave me that we are, 800 feet from Mount Rushmore. So that's 800 one right there. Then if I look at the next part, it says the angle elevation to the bottom of the sculpture. So I know it's going to be an angle elevation, so it's going to go in the corner, but it's to the bottom of the sculpture is 32 degrees. So if I zoom in here, it's to the bottom of the sculpture is 32 degrees. And then the angle to the top is 35 degrees. So I have to fill that in. So that's the angle from the same person, but now to the top of the statue. A little bit straighter line there. That angle is 35 degrees. Our goal is to find how tall his face is. That's what we're trying to find right now. But that technically right now is not part of a right triangle. We need to focus in on the right triangles that we see here. So we're going to look at this red right triangle first and find its missing side. I'm going to be able to find x over here. And then I can look at the next triangle in a minute. So we're going to find x first. So zoom back out. If I want to find x right now, I'm going to use, that's opposite and adjacent. So I'm going to use tangent. So it's going to be tangent of 32 degrees is equal to x over 800 times both sides by 800. And I would get x is equal to 499.9. Then we're also going to do something with that 35 degrees. What we have to do with the 35 degrees is look at the triangle it's a part of, which is this bigger right triangle here. Is we're going to set up a problem with that. That is going to give us this whole side, though, because we're looking at that big triangle. It's going to give me that big side that I just called y in the picture. So we're going to do tangent of 35 is equal to y over 800 times both sides by 800, and we will get y is equal to 560.2. But again, the goal was to find where I put that question mark right here, is just what's the height of his face. That's all we wanted to know. But we had to use each individual triangle first, And now if I wanted to know that piece, it's just simply a geometry problem. We're trying to find that top part. We know the bottom part is the 499.9 and the whole thing is 560.2. So all we got to do to finish this problem to figure out the height of his face is we're just going to subtract. So it's going to be the 560.2 minus the 499.9, and that would tell me that his face is 60.3 feet long. Alright, we've got one other type of problem that's similar to this.